So in this video, we're going to talk about dynamic equilibrium and the Chatelier's principle, but this time it's the exam style questions. So really, really important. So if we look here, carbon monoxide, first MCQ, we're going to go 3 MCQs first of all, and you can see it's an exothermic reaction, minus 40. Which change will shift the position of equilibrium to the right, so make more yield, right? To the right-hand side. So you want it to go to the right-hand side. So first of all, we were talking about pressure, talking about temperature. Well, let's count the number of moles on each side. 1, 2, 3, 4. So therefore, there is 4 in total and 2 on each side. So 2 on each side means the same on each side, which means I can change the pressure all I want. It doesn't make any effect to the equilibrium yield, okay? So that means those two are wrong. We then go for temperature. Well, that is exothermic, which means if I want it to go in that direction, if I lower the temperature, it will follow the exothermic direction and get hotter, which means that I need to decrease the temperature so that it forces it to go to the right. That's your MCQ 1, very, very common. Okay. So as you can see, I am here on a different day recording this, different top. But anyway, let's go through MCQ number 2. So I'm going to go through each one quite quickly. Which statement is not correct? So which is not correct? Okay. So if we look here, let's look at the first one. The concentration of the products and the reactants are the same. Well, if we go through equilibrium, they can be totally different concentrations. The only important thing is that they stay at the same concentration. Okay, so the answer is A, but let's go through why B, C and D aren't. The equilibrium can be achieved from both sides. Well, that is correct. You can just start from where you want and it will get to equilibrium. The rate of the forward is equal to the rate of the reverse. Well, that is the definition of equilibrium, so C is correct. System is closed, got a lid on. So therefore, that's absolutely perfectly correct. So the answer for this one, which I should have picked up my little clicker for, okay? So the answer for this one is going to be, there you go, A, with the green one, okay? Let's move on to the next question. So next question, we've got a catalyst. Now, a catalyst does the following. A catalyst will speed up the rate of both the forward and the backward reactions to the same effect, okay? So that's what it does. It means you can get to equilibrium quicker, but it doesn't affect what the equilibrium values are. It just means you can get to them quicker. So let's have a look at the answers. There's no effect on the rate in either direction. Well, that's not true. Both speed up. Both rates increase by the same factor. Well, yes, that is true. So that is the true one. The rate in the forward increases by a greater factor than the reverse. Well, that's wrong because we know it increases by the same factor, which is B, and that's why D is also wrong. So we have an answer of B. So let's move on to our next one. Now this is a short answer question, calculating Kc. So you can see a chemist investigates the equilibrium, produces methanol. We've got this beautiful equation here. It mixes CO and H2 until the equilibrium. The equilibrium mixture is analysed and found to contain the following concentrations. So basically it has the following concentrations, which you can see right here. Now it's telling you that at equilibrium, which means you just need to put them into the equilibrium expression. Okay, so let's put that to the side. So we've got to calculate the numerical value. First of all, we need the expression. So the expression is here products. So I've taken products. My product is CH3OH over reactants, and I raise it to the power of the numbers in the equation, the coefficients, right? Those numbers here. I've got that there, and all I do is take those numbers and I put them in. And you've got to get used to doing this in the calculator. I've said this in other videos. Get used to doing it in the calculator and knowing how your calculator works. And then we get 14.6. And it says, give your answer to an appropriate number of significant figures. It doesn't ask for the units, but we've given the units anyway. Look here, there is 1 on the top, there is 3 on the bottom. So you cancel out 1 of the moles per decimeter cubed, leaving you 2 moles per decimeter cubed. 2 times moles per decimeter cubed is this. Remember, raising it from the bottom to the top is like timesing by -1. That's why you end up with that. If you're not sure about that, the previous video on this will tell you how to do units. Next one. So we're going to talk about the equilibrium constant again. Again, we've got methanol again with this kind of setup. And we've been given equilibrium mixture. Write an expression for that. So this is a very simple one. Okay, and you can see the value for this is there. So all we do is determine the equilibrium concentration of methanol for this question. Okay, so we've got to write the expression and we've got to determine the equilibrium concentration of methanol this time. So in our equilibrium mixture, we are given CO, and we're given H2. We're not given methanol. Okay, so let's do the expression again because we did it before anyway. So here is our expression, and then here is our expression with the numbers put in. So you put the numbers in, you put the ones you know in, and then you're left with CH3OH. Well, you've got to rearrange that now. So I'm just going to rearrange that, 14.6. I'm timesing all of this up here, okay, and that will equal my CH3OH, which is 2.61 times 10 to the minus 7. Now I've gone through that quite quickly, but hopefully if you're good at maths, you can see that I'm just rearranging this equation here to get my concentration of CH3OH. It's probably one of the most difficult questions you'll get if you're doing the AS exam. Now, if you want to do more complicated ones, remember, there's many more videos on this in Module 5. Okay, let's go to the next one. Ammonia is used in the manufacture of nitric acid. The first stage of this is dynamic equilibrium. So here we have a equation. It says when the temperature is increased, Kc for this reaction decreases. State the effect, if any, on the equilibrium yield of NO in this reaction. Explain your answer. Let's put it to the side. So we want to find out what happens to NO, okay, when we increase the temperature. So what is that effect on the yield of NO? So basically we need to know whether the equilibrium is going to the right or the equilibrium is going to the left. Is it right? Is it left? Okay, so how do we do this? Well, first of all, let's have a look at the expression, and you can see at the expression here is products over reactants, okay? So at that point, what we're going to say, if we get an arrow going down here, right? So let's have a think. First of all, we're going to look at Kc for this reaction decreases. Well, Kc is equal to products over reactants. So products over reactants, okay? Because it is products over reactants, okay, when the temperature is increased, Kc decreases. This means this number must get smaller for Kc to get smaller. Okay, this number must get smaller for Kc to get smaller. Okay, which is why we've got the arrow here saying that gets smaller. It's because Kc has decreased if the temperature's gone up. Now, if that's decreased, because it's in equilibrium, so if this has decreased, the reaction that way has got to have increased its rate of reaction. So the bottom one should go up, which would exacerbate the whole thing and makes Kc even smaller, which then would push that Kc down. If that is the case, the equilibrium is going to the left, which means you produce less NO. So yield decreases and the equilibrium position has moved to the left. Okay, hopefully you understand that now. Let's go on to our next question. So our next question is an LOR question. This is a level of response questions. They usually have 3 levels, 1, 2, and 3. So 1, 2, and 3. So if we look at this one, we can see we've got to do our expression again. Things to note, it is a negative, which means it's an exothermic reaction, okay? So that's the first thing. And moles, let's look at moles. 3 moles on the left, 2 moles on the right. These are the type of things you need to look at straight away. Now, let's look at the question. Explain the conditions of temperature and pressure. So it's a good thing we did that because we now know what we're doing, hopefully. Okay, that will be used to obtain the maximum equilibrium yield of sulfur trioxide. So we want the equilibrium to go to the right. Okay, let's put this to the side. Okay, so we've got here the yield. Increasing pressure increases the yield of SO3. Why is that? So what you've got to do is think about the number of moles. And we've got here, increasing pressure increases yield of SO3. Let's get me out of the way. Hello. Okay, and that increases the yield of SO3. That must mean there's more moles on the reactant side, because if you increase the pressure, it's going to move to the side with the least moles. The side with the least moles is the right-hand side, which means it goes towards the right. So that means increasing the pressure will push it to the side of the least moles, which is the right, which means you'll get more SO3. Now at the same time, it does say at the bottom, discuss the importance of a compromise between equilibrium yield and reaction rate. So therefore, the importance means you have to discuss rate as well. And that's where you say there, pressure just increases rate. There's more particles in a smaller space, or you put in the same space more particles. Okay, so basically we're reducing the size of the container, or we're pumping more particles in. But either way, there's more collisions, which means a higher rate. So we've got our 3 points here. Now, that means we have talked about pressure. So let's talk about temperature. Okay, so decreasing temperature, let's get me out of the way here. Okay, decreasing temperature increases the yield. Now, why is that? It's because the forward reaction is exothermic. Because the forward reaction is exothermic, so it's exothermic in the forward, if you decrease the temperature, it's going to want to do the opposite and make it hotter. It follows the exothermic reaction. Now, the last bit is rate is increased by temperature. So you've got 2 points on each level, okay, and that's how you get your 6 marks in here. Now, the last bit is the compromise situation. You would choose a higher temperature, which creates a reduced yield, but in a shorter space of time, okay, so shorter time. Okay, so that means increasing pressure increases the yield of SO3 because there are more moles on the reactant side or less moles on the product side. Okay, and increasing pressure increases rate. We've also got decreasing temperature increases the yield of SO3 because the forward reaction is exothermic, and temperature increases rate. Now, the important thing down here, and I know I haven't put the extra little bit on the bottom here, but I'm going to say it a couple of times. Choose a higher temperature which creates a reduced yield but in a shorter space of time. So less time. That's what you've got to say. Now, these are all the type of questions you would face in the first year of your A-levels in the exam. They don't go differently from this. So if you make sure you can do all these type of questions, you will be well prepared. Happy days.